In this lecture, we're going to look at the hazards that are associated with volcanism and how we go about monitoring volcanoes. So here goes. So some hazards include pyroclastic flows, lahars, which are also referred to as mud flows, pyroclastic fall, lava flow, noxious gases, and earthquakes. So here we can look at that historically volcanic fatalities are 92,000 in Tambora, which is in Indonesia in 1815, 36,000 in Krakatoa, Indonesia. This is arguably the loudest sound ever heard since the industrial world began developing, right? Even in 1883 it was still considered that. 29,000 Mount Pelée, that was in 1902, and 15,000 occurred in Japan. So these are kind of your top four. But volcanoes cause fewer fatalities than earthquakes, hurricanes, and famine. So when I look at pyroclastic flows, one of the first of the hazards, we're looking at an example of Mount Vesuvius. In 79 AD, it destroyed the city of Pompeii. So you had this extremely massive eruption, but it was the debris that fell down that was full of hot gases and this ash and dust that eventually buried the city. And on August 24, 79 AD, Mount Vesuvius literally blew its top, erupting tons of molten ash, pumice, and sulfuric gas into the atmosphere. The pyroclastic flows then kind of moved over the city of Pompeii, and it surrounded the entire area. And the city of Pompeii was later unearthed. That means kind of found within this volcanic rock. And they're like, wow, there's a city here. So pyroclastic flows included the poisonous gases and hot volcanic debris that engulfed the city of Pompeii, and then a couple other cities, and suffocated the inhabitants, burying them, including the buildings. So this is how they were found, and their bodies would have been literally become the cast that the rock and debris would have then re-solidified around. So it would have then recrystallized, and these are just mummified bodies that the body themselves has decomposed. And that was left. And this is a picture of a dog that was clearly trying to outthink the eruption. But the cities remained buried and undiscovered for almost 1,700 years until excavation began in 1748. And these excavations continue today and provide insight into life during the Roman Empire. So you use this city that was covered or buried in volcanic debris to study the anthropology, and you do this through archaeological sites. So Vesuvius today, if this is a cross-section of A to B, you'll see that from A to B here, when I look at it within this cross-section itself, you'll see that there's a subduction zone lying right here, a convergent boundary, and that's what this picture right here is showing you, those triangles. Subduction's taking place. This is a plate boundary here, if you can read that it's subducting beneath the continent, or excuse me, beneath Italy, the country of Italy. And that's just a result of the types of felsic, possibly even perhaps slightly intermediate magma that just has a high viscosity that's going to lead to a major eruption. So the geologic story should make sense. And here's a picture of Vesuvius from above. That Vesuvius remains a hazardous volcano with heavily populated flanks. So there's large populations here, along the coast, along the northwest side. So about 1.5 million people living around the cities, and it's pretty close, 15, 20 miles from Vesuvius. And pyroclastic flows can flow up to 100 kilometers, or about 70 miles from the source. So they are within the dangerous area. So pyroclastic flow, direct impact. So this debris that's traveling up is eventually going to cool and solidify, and it will fall down. So here's a town prior to this pyroclastic flow, and here's what it looked like afterwards. And this was a particular rock that was left here, and just kind of a cool emphasis on what can take place with pyroclastic material. More pyroclastic flows that can actually bury cities, can deposit inches to feet of hot volcanic ash, and very few people get out of these alive. I mean, you're pretty much, if you're consumed in it, that kind of seals your fate. Pyroclastic flows also include burns. You can actually find burns within trees. They are literally burned as they are, as wherever you find them. Entire forests can be completely consumed or burned as a result of the pyroclastic, really the hot material. Here are lahars. Volcanic activity melts snow and ice, right? A lot of volcanoes are high in elevation. It's colder up in elevation, The meltwater picks up rock and debris, and these form very fast-flowing, high-energy torrents and destroys pretty much everything in its path. It pretty much just kind of wipes out everything in its path. And those are called lahars. Here we have Pyroclastic Fall. This involves the ash clouds that come down, much like that of snow, but it's not snow. It doesn't melt. You have to wait for rain, or you have to manually move it. And, you know, this is daylight. That's the sun right there. So it can collapse roofs, bring down power lines, kills plants, obviously inhibits photosynthesis, contaminates water supplies, and is a respiratory hazard for humans and animals. So when it's airborne, it's a problem. And then lava flows. These are effusive lava flows that consist of basaltic lava. These are low silica content, right? Low viscosity, roughly 50% silica content. And these are ones that make for very, very colorful eruptions. And this one here would not be considered eruptive. Those are pretty well contained. You know, I don't know the height of that, but it's not blowing up. It's simply just erupting basaltic magma. So here's some cool pictures of those. So when we go back and we look at all of the different characteristics that can take place with the volcanic hazards, this lecture slides were just kind of showing you examples of what takes place here. Within the pyroclastic flows, within the lahars, pyroclastic falls, the lava flow, noxious gases, and earthquakes. And really, this picture makes a lot more sense when you look at, well, it's not just this, it's really not even the lava that becomes the problem. It's this up here, this plume, this debris field that creates a whole heck of a lot of problems for whoever's downwind. So if the prevailing wind is from right to left, if you're in this path down on this side of it, the wind is going to deposit and deliver all of this on top of you. And that becomes a problem.